breathlessness, hyperventilation, and shallow water blackout. So breathing correctly is important. However, sometimes we get breathless and take a succession of fast, superficial and involuntary breaths. Let's find out why. When we breathe normally, we use a minimum part of our lung volume, just half a litre or quart of a total capacity that can vary from 5 to 8 litres or quarts. Before the air we inhale arrives in the operative area of the alveoli, it travels through a series of rigid cavities, the nose and mouth, pharynx, larynx, trachea, bronchi, etc., where gas exchange does not take place. For this reason, these spaces are known as dead air spaces. The volume of these spaces is around 0.15 to 0.20 litres or quarts. Therefore, every time we inhale, the first air that arrives in our lungs is the air we exhaled the last time we breathed out, and which stayed in the dead air spaces. This air does not increase the oxygen content in the lungs. Instead, breathing more deeply improves respiratory efficiency because it increases the volume of fresh air we inhale with each breath. Although our bodies burn oxygen, the main stimulus to breathe is activated by the amount of carbon dioxide there is in our blood. If respiration is superficial, it is not very efficient, and the amount of carbon dioxide we eliminate is not enough to slow down the stimulus to breath. In this way, a vicious cycle is created that makes you breathe faster and superficially and gives you a sensation of air starvation. You are out of breath. To overcome this difficulty, stop the activity making you breathless and take deep breaths and try to expel as much air as possible from your lungs. This helps to eliminate the excess carbon dioxide and take in a larger quantity of oxygen. These deep breaths, with prolonged expiration, that help you overcome an attack of breathlessness are similar to those that the free diving record holders make before they descend, but the objective is different. In both cases, these deep breaths are made to lower the level of carbon dioxide in the blood. However, in a case of breathlessness, it is to bring the level back to normal, while with hyperventilation, this is the technical name for this method of breathing, free divers try to get the level as low as possible, well below the normal level, so as to delay the stimulus to breath. Contrary to what you might expect, hyperventilation does not significantly increase the oxygen content in the lungs or blood. Therefore, hyperventilation does not increase the amount of oxygen available, but it only delays the stimulus to breathe. Prolonged hyperventilation can therefore be dangerous, because the level of oxygen may get very low before the level of carbon dioxide stimulates the diver to breathe during a free dive. If the level of oxygen in the body is too low, it can cause us to black out or faint, which can obviously be extremely dangerous in the water. This type of blackout generally occurs in the last few meters, feet, towards the surface due to the fall in pressure. The best and easiest way of prolonging your free dives is to move calmly in the water and relax mentally. The safest way to free dive is to use the buddy system. Each diver should take it in turns to dive under the water, and while one diver is under, the other watches from the surface, ready to intervene if necessary. Obviously, the dives must be no deeper than the depth that can be reached easily by both divers. These few and simple rules make free diving safer and more fun.